Hello, everyone. Thanks a lot for giving me the opportunity to talk to you, even though, as you can see, I am a JavaScript developer, and therefore not the highest of powers are available to me. This is probably not the best language to crunch pixels and do everything super efficient, but JavaScript is still very important for two reasons. The first one is there are many of us, big community of developers, and they also want a piece of the video pie. And the second part is the web. An empty index.html file is a canvas where you can draw almost anything. We have vector graphics, you can render text, and it's all so easy, relatively. I am one of those people who at one point realized, actually it's easier for me to draw on the web using CSS than it is for me to use a program like Photoshop or After Effects. And yeah, so we can also animate on the web. Now the question is, what is the easiest way to turn this into a video? The easiest way that I could think of is, we open up a cool JavaScript animation and think Command, Shift, 5, and we start screen recording. And in the end, we have generated a video. Let's talk about what is good and bad about this. The good thing is, we have generated the video, so this is completely viable. Many people do this and post their videos, I believe. The bad thing is the video resolution is limited to the resolution of your display. So I noticed this projector is like 960 pixels high, so we can almost create a full HD video, but not quite. So that's for sure one restriction of this approach. Then how would we automate this? How could we programmatically screen record the browser? That's for sure another thing to ponder about. And also, what if we drop a frame? What if we have expensive graphics and they take longer to render than 33.33 milliseconds in the case of us wanting to create a 30 FPS video? So based on these questions, how could we do it a bit better? Who knows this legendary ffmpeg command? So I think it's been used billions of times. It takes a series of images and converts them to a video. And to generate these images, it's also relatively easy. We can take screenshots with Puppeteer, right? So this is the concept that I've taken and taken to a certain point. This is my framework Remotion, and now we are entering the React space. In here, we have a React component, and at the top, we always use a hook, use current frame. That is a time value. And so let's say we take control of the time and pause the video, and for whichever time we are currently at, it is now our responsibility to render an image. It can be any DOM content. Here, as you will see shortly, I've just rendered the RTC.On logo. And using this simple math function, we can interpolate the time. Here, I have said that in the first 10 frames, the image should scale from 0 to 1, and then at the end, it should scale down again. Now, I have made a preview editor for this. And we have a timeline where we can scrub through, but also we can play and pause the video, and we can increase and decrease the speed. Because we have taken control of the time, because we have used this hook, this would not be possible with normal CSS animations. Yes. And that is the whole concept of Remotion, the library that I maintain. And of course, just this is pretty hard to do, so we also develop a whole ecosystem of packages. So whether it's about how to synchronize a GIF or a 3JS animation with this useCurrent frame hook, we ship many packages for that. And based with this primitive, which is essentially just screenshotting frames and then encoding them using ffmpeg, we can create videos. The easiest way to render is using this render button. We have a variety of options here. Essentially just a wrapper around ffmpeg flags. And we can render this into a video and play it back. There are also other ways to render using the CLI, using a Node.js API, in the cloud, and Docker using lambda functions, which I'm going to demo later. So yeah, now that I've explained what Remotion is, I mean, for you this is baby steps, right? Many of you are solving much more difficult problems, and I've thought about what could I talk about that could be of interest for you. And I've decided to just briefly mention 2 areas of work that I am doing, where I go deeper into the video creation pipeline, explain a bit what I did there, and then if you are more interested in it, then we can talk about it later. One big challenge is embedding videos into our video. So we have an existing video, we could use a video tag and maybe add some overlays. That would be a use case for it. And how we solved it initially is just using the regular HTML5 video tag and then making a component which synchronizes the video tag's frame with our hook. And this worked well. It also worked well for 2 videos. It worked kind of well for 4 videos. But then there are always the people, they want to render 16 videos or 32 videos at the same time. At some point, Google Chrome just says, no, stop, I will not render any more video tags. And a significant amount of people wanted to do that, so that pushed us to research how could we do this better. We created another component called off-thread video, and what it would do is, in the preview, it would still use the video tag because there's nothing better we can do, I think. But while you are rendering the video, we are actually rendering an image. That image has a source which calls a server of ours, and that server then uses ffmpeg to extract the video frames. And that worked. Now you could actually render a video with 32 other images in it, but from a performance perspective, it was not so good. Because if we use the ffmpeg CLI, we extract 1 frame at a time, and the user could also play the video in reverse. We don't know what the next frame is going to be. So we would extract 1 frame at a time, then the CLI would quit, the stream gets closed, and for the next frame, we have to do the same thing again. And many frames in videos are just interpolations of the previous frame, so we also have to do all of this work again. So this meant that using the ffmpeg CLI was also not good enough for us. And so I've dug deeper and started using C, or just the ffmpeg C API in Rust, but nonetheless, I'm proud of it. And what I have built is a Rust program which uses the ffmpeg C API to open a video, extract frames whenever it is needed, can also already take the next frame based on, most likely it's going to be the actual next frame in the video, and then does some in-memory caching, which is also tricky because although a video file is small, once you extract the bitmap from it in a full HD video, it's 8 megabytes. So you really have to manage the memory well, otherwise people have to buy a lot of RAM sticks. And yeah, that is now available in Remotion. I think the coolest thing about it is that we have managed to cross-compile this for 7 platforms, all major operating systems, for both x86 and ARM, and kept the option to use the ffmpeg CLI alive. So the ffmpeg libraries are one thing, and then we have a tiny Rust program that depends on these libraries, as well as the CLI, without having to double the disk size. And then, so I think that is something pretty cool, and if you're interested, then I will be happy to talk to you about it. Up next, oh no, first I wanted to mention that when going deeper and using this ffmpeg API, you really start to realize the complexity that a video format has. I really was so naive and thought, okay, I could just play this video in a video tag and everything would be fine. But the deeper you go, the more control you have over things like pixel formats, color spaces, presentation timestamps, and we have already heard earlier today about how cursed they are if they are non-monotonous. And I could also tell you many more horror stories about this, but I think I will not take the time to rant now. But if you want to hear a horror story about this, you can go to Twitter and search Rusty Jonny and the cursed MP4 file, and then I will tell you a story about a really cursed MP4 file and how I solved the problem with Rust. All right. Another area that I'm focusing on is rendering in the cloud. Because I think that is the biggest strength of Remotion. Unlike programs like After Effects and Premiere that are used for motion graphics usually, we can run this on regular Linux environments. And one opportunity that I saw was to create a distributed video renderer on AWS Lambda. And this, I would like to show to you how it works. So the video that I've shown to you before, I've made it now 15 minutes long and used our loop component. So it's a pretty long video. And now what we are going to do is we're going to render this 15-minute long video on AWS Lambda. We're first going to spawn one single Lambda function. And this Lambda function is going to recursively call itself 150 times. Each one of these Lambda functions will render a few seconds of video. They will send the video back to the original Lambda function. And if everything goes well, we will have a 15-minute long video. So I'm starting it now. Meanwhile, you can see we get some logs as well that we can look at later. And now we are rendering the frames. All 150 Lambda functions are now alive. And we are already nearing the end of the rendering the frames with Puppeteer phase. Now the chunks have been encoded into MP4. And here we go. In just 30 seconds, we have rendered a 15-minute long video for 10 cents. And now the lambdas are all shut down again, and we don't need to pay anymore. So I have to admit, though, that I cheated a little bit because I didn't render the audio of the video. If I were to do that, it would take maybe like twice as long. This is because combining the H.264 chunks into a long video is really fast. There's almost no overhead. But for the audio, it is a bit more tricky. If we render AAC chunks and then stitch them together, we get this tiny popping, crackling sounds in the seams at the points where it's being stitched together, and that doesn't sound nice. So what we do instead is we create PCM audio, first stitch together the uncompressed audio, and then in this combining video phase, we re-encode the whole 15 minutes of audio into AAC. So then it takes usually twice as long. Now it was a bit faster because now the lambdas are warm. Yeah, if anybody knows how to solve that, I would for sure it would be a game changer to us. Maybe someone is good enough. And looking at the logs, you can see that we really spawned the lambda function 150 times. And that we rendered all the frames using an ffmpeg command. And yeah, I think that's a pretty new way that we developed over the past 1.5 years, and that seems to work out, except the things we haven't yet figured out, the audio and also like the color space stuff and that. I'm still learning about it, but how I'm developing I'm just putting out new releases like every 2 days or so, waiting for feedback from people to use it. They also send a lot of cursed videos, which I then try to handle, and that is how we somehow managed to create a pretty scalable system. And yesterday I got a message from a customer. They rendered 400,000 videos using this Lambda solution in the past 30 days. So yeah, that is for sure one thing that I'm also happy to have this course about afterwards. If you want to follow me, then like I said, I'm actually here until Monday morning, so come talk to me. I'm on X. I have a YouTube channel. If you want to learn more about Remotion, you may visit our website, or make your first video today by typing in npm init video to the command line. On our YouTube, we also have more tutorials, and we are also on X, Instagram, and TikTok, where we are trying to capture the Gen Z JavaScript programmers. Thanks a lot.
Thank you very much. All right, are there any questions for Jonny?
So, I would like to ask why you have decided to use Lambda functions instead of, for example, node groups and like some kind of microservices on the EC2?
Instead of coroutines?
Instead of node groups on AWS.
Node groups. I don't even know what it is. We have also experimented with Cloud Run just to diversify a bit. Some people don't like AWS. This is just the first thing that we've tried. We went for Lambda functions because AWS is the biggest cloud, and it seemed the most obvious. But I could imagine doing other types of orchestration as well.
Okay. Is there anyone else who would like to ask a question? Okay.
Thank you for the talk. You mentioned Puppeteer. I have actually 2 questions. So first one, what role did it take in the process? And second question, do you know any alternatives to Puppeteer? That would be interesting.
Yeah. So the first question was, how does our process work? So with Puppeteer, you can open a page, you can screenshot it. Actually, what we do is we open 4 tabs and then screenshot all of them in parallel so the video can render even faster. We first bundle our React code. That is also a requirement before you can send it to the, before you can render the cloud, because your node modules folder is way too big. And alternative to Puppeteer, I mean, how you interface with the browser is actually the Chrome DevTools protocol that is implemented even in other browsers. And so you could implement this yourself or use Playwright. It's all the same thing, all the same protocol. That's also a limitation, I have to say, because when we get the screenshots, what Chrome will actually do, and there is no other way currently, is it will encode it into a JPEG and then base 64 encode it, and then you get the picture back. So I see a huge opportunity to make it even faster, for example, by forking Chrome or using, we've actually thought about it, or using like Chrome driver or I think there are other C++ projects where you can embed Chrome.